Hey y'all, today is January 14th, and in our lesson today we talked about solving two-step equations. So we're just going to do a little mini lesson on how to solve two-step equations. So grab a pencil, a piece of paper, and your calculator, and let's get started. So we're going to start right here with number 1. And my first step, the thing I always do first, is draw a line through my equal sign. That helps me see that whatever I do on one side, I must do on the other, and that helps me keep everything balanced. Now, I'm trying to get this x right here by itself. So I'm going to work my way from the outside in. So I'm going to isolate or get the term with the x by itself. So that includes the 2x. That's all one term together. I'm going to get that part by itself first. So that means I've got to do something with this -5. Well, because that's a -5, to get rid of it or undo it, I need to add 5. And I'm going to add 5 on both sides of my equal sign. Remember, that's what keeps everything balanced. So now on the side with the x, the 5's cancel out, and I'm left with 2x equals, now on the other side, 13 plus 5 is 18. Now, I'm still working to get that x by itself, and x is connected to 2 through multiplication. So how do I undo that multiplication? Well, I simply divide by 2, and I'm going to do that on both sides because that'll keep everything balanced. On the side with the x, the 2's cancel out, x is by itself, and on the other side, 18 divided by 2 is 9. So x equals 9 is my solution. Now I can still plug that in to check my answer. So I'm going to do that right here. We have -5, oops, change back to my pen, sorry, -5 plus 2 times 9 equals 13. Well, we know that 2 times 9 is 18, so I have -5 plus 18 equals 13. Well, what is -5 plus 13, or sorry, -5 plus 18? Well, I'm adding integers with different signs, so I'm really going to subtract. 18 minus 5 is 13, and my bigger number was positive, so I need this to be positive. So 13 equals 13. It's the same number on both sides, so I know that my answer was correct. Let's move on to number 2. Always start by drawing a line through your equal sign. That will help make sure that whatever you do on one side, you also do on the other. Now, I'm going to try to get this in right here by itself, and I'm going to work my way from the outside in. So I'm first going to have to do something with this -3. So how do I undo subtracting 3, or how do I undo a -3? If you said add 3, you're right. So I'm going to add 3, and I'm going to do that on both sides. So on the side with the n, my 3's will cancel out, and I'm left with -n. On the other side, I have -1 plus 3. Because I have integers with different signs, I'm really subtracting. 3 minus 1 is 2, and my bigger number was positive, so I know that my 2 is positive. Now, it looks like my n is by itself, but it's not by itself. Because it has that negative in front of it, I have to think of that as a -1 attached to it. And how is that -1 attached to it? Well, it's attached through multiplication. So I undo that by dividing by -1 on both sides. So now on the side with the n, my -1's cancel out, and n is by itself. And on the other side, 2 divided by -1 is going to be -2. So my solution is n equals -2. Now to check it, I just simply plug that in. So I have -2 minus 3 equals -1. Okay, so now remember, when you have a negative and then a negative, when you have two negatives next to each other, that's really a positive. So I really have 2 minus 3 equals -1, and 2 minus 3 is indeed -1, so -1 equals -1, same number on both sides, so I know that my answer is correct. Okay. So now moving on to number 3. So draw a line down my equal sign. And I'm trying to get this r by itself eventually. So I'm going to try to get this term by itself itself, that means I have to do something with that -3 that's out in front. So I'm working my way from the outside in as close to the R as I can get. So starting on the outside, I've got to get rid of that -3 that's out in front. Well, what's the opposite of -3? It's a +3. So I'm going to add 3, and I do that on both sides to keep everything balanced. On the side with the R, my 3's will cancel out, and I'm left with -3R, and that's equal to 21 plus 3, which is 24. So now I'm still trying to get that R by itself. How is it connected to -3? It's connected through multiplication. So how do I undo that? I divide. So I'm going to divide by -3 on both sides. Now on the side with the R, the -3's cancel out, and R is by itself, and 24 divided by -3 is -8. So R equals -8. That is my solution. Again, we can always check our solution by plugging it in. So we have -3 minus 3 times -8 equals 21. Okay, so let's start with this multiplication here. -3 times -8. A negative times a negative is a positive. So we have -3 plus 24 equals 21. Okay, so again, that's a positive 24 because like we had mentioned before, a -3 times a -8 gives you a positive product of 24. So now we have -3 plus 24. Integers that we're adding together, they have different signs. So I'm really going to subtract. 24 minus 3 is 21. My bigger number is positive, so it stays positive. So 21 equals 21. Same number on both sides, so I know that my answer is correct. Okay, moving on to number 4. Always start by drawing a line down your equal sign. And our goal, remember, is to get that D by itself. So I'm going to work my way from the outside in close to the D. So that means that I have to do something with this 5 first. And notice that's a positive 5 because we're adding 5. So how do I undo that? Well, I subtract 5. And I have to do that on both sides. So on the side with the D, the 5's will cancel out. 4D comes down, and it's by itself. And on the other side, 13 minus 5 is 8. Okay, so now I'm still trying to get this D by itself, right? So to get that D by itself, I know it's connected to 4 through multiplication. So we undo that by division. So I'm dividing by 4 on both sides. On the side with the D, my 4's cancel out. D is by itself, and on the other side, 8 divided by 4 is 2. So my solution is D equals 2. We can always plug that in to check our work. So we have 4 times 2 plus 5 equals 13. Well, we know that 4 times 2 is 8, so we have 8 plus 5 equals 13. 8 plus 5 is 13, so 13 equals 13. Same number on both sides, so I know the answer is correct. Let's move on to number 5. So this one looks different because it's got that fraction in it, but it's really not that different. Okay, so my objective is to get that B by itself, and I'm going to work my way from the outside in. So the outside in means I'm trying to get this by itself first. So I've got to do something with this -1 that's out in front on the outside, right? Well, what's the opposite of a -1? A positive 1, right? So I'm going to add 1, and I'm going to do that on both sides. So on the side with the B, my 1's will cancel out, and I'm left with B over 2. And that's equal to 1 plus 1, which is 2. Okay, now I'm still trying to get this B by itself. And B is connected to 2 through division. So how do I undo division? Well, I multiply. I'm going to multiply by 2. And I'm going to do that on both sides to keep everything balanced. So on the side with the B, the 2's cancel out, and B is by itself. Now on the other side, 2 times 2 is 4. So B equals 4 is my solution. Can I still plug it in to check? Yes, I sure can. So let's do that real fast. So we have negative 1 plus 4 over 2 equals 1. Well, let's start with 4 divided by 2. We know that 4 divided by 2 is 2. So we have negative 1 plus 2 equals 1. So now, on this side right here, I have two integers that I'm adding together, and they have different signs. I'm really going to subtract. So 2 minus 1 is 1, and my bigger number was positive, so it stays positive. So 1 equals 1 is the same number on both sides, so I know that my answer is correct. Okay, let's look at number 6. So first things first, draw that line down that equal sign, and understand that we're getting that k to be by itself. So in order to get that k by itself, I need to work my way from the outside in. So that means that this has to get by itself first. And for that to be by itself, I have to do something with this negative 4. Well, because that's a subtracting 4, what's the opposite of that? Adding 4. So I'm going to add 4 on both sides. On the side with the k, the 4's cancel out, and I'm left with k over 3, k divided by 3. Okay, now on the other side, I have negative 1 plus 4. I'm adding integers with different signs, so I'm really going to subtract. 4 minus 1 is 3. My bigger number was positive, so it stays positive. Now, we're still trying to get the k by itself. And in order to get that k by itself, I need to undo dividing by 3. Well, how do I undo dividing by 3? I multiply by 3. So I'm going to multiply by 3 on both sides. On the side with the k, the 3's cancel out, and k is by itself. On the other side, I have 3 times 3, which is 9. So k equals 9 is my answer. We can always plug that in to check our work. So we have 9 divided by 3 minus 4 equals negative 1. Well, let's start with 9 divided by 3. 9 divided by 3 is 3. So we have 3 minus 4 equals negative 1. Now 3 minus 4. I know that 3 minus 4 is negative 1. So negative 1 equals negative 1. It's the same number on both sides of the equal sign. So I know that my answer, k equals 9, is correct. Okay, number 7. So let's draw a line down our equal sign first. And let's also understand that we're trying to get that a by itself. Now, when we look at this, we have a plus 5, all divided by negative 4, equals negative 3. So I want to clear this fraction, make it not a fraction anymore. And we remember that if we have a over 2 equals 5, to clear that fraction, I would just multiply by 2 on both sides, because fractions represent division, right? So I'm doing the same thing here. So to undo dividing everything by negative 4, I'm going to multiply by negative 4. And I do that on both sides of my equal sign to keep everything balanced. So on the side with the a, my negative 4's cancel out, and I'm left with a plus 5. On the other side, I have negative 3 times negative 4. Careful, they're both negative. So a negative 3 times a negative 4 is positive 12. Now I'm ready to get that a by itself, and it's a little bit easier because it's connected to a positive 5. How do I undo that? Well, I subtract 5 on both sides. On the side with the a, my 5's cancel out. A is by itself. 12 minus 5 is 7. So a equals 7 is my solution. Now we can always plug that in to check our work. So we have 7 plus 5 divided by negative 4 equals negative 3. Well, let's first figure out what 7 plus 5 is. 7 plus 5 is 12. So I have 12 divided by negative 4 equals negative 3. So 12 divided by negative 4, a positive number divided by a negative number, gives us a negative quotient. So it is negative 3, and negative 3 equals negative 3, same number on both sides. So I know that my answer is correct. Okay, last one, number 8. It's very similar to number 7. Let's start by drawing a line down my equal sign. Now, I would like to get rid of this fraction here. And remember, fractions represent division. So how do I undo that I'm dividing everything on this side by 2? Well, you undo division with multiplication. So I'm going to multiply by 2. And I'm going to do that on both sides. Now, on the side with the x, because that's what I'm trying to get by itself, on the side with the x, I know that these 2's are going to cancel out, and I'm left with x minus 3. Now, on the other side, I have 2 times negative 11, which is negative 22. Okay, so now I'm still trying to get this x by itself. And it's connected to a negative 3. It's subtracting 3. So how do I undo subtracting 3? Well, I add 3. And I do that on both sides. Okay? So now, on the side with the x, my 3's cancel out, and my x is by itself. On the other side, I have negative 22 plus 3. So think of these as integers with different signs, right? And because they have different signs, we're going to subtract. So 22 minus 3 is 19, but it keeps the sign of the bigger number, so it's negative 19. So negative 19 equals x, or you could write that as x equals negative 19. Okay, we can still check our work by plugging this in. So we have negative 11 equals negative 19 minus 3 divided by 2. Well, let's start by simplifying negative 19 minus 3. So that's 2 integers that have the same sign. So I'm going to add them together. 19 plus 3 is 22, and it stays negative. So negative 11 equals negative 22 divided by 2. Well, negative 22 divided by 2 is negative 11, so negative 11 equals negative 11. Same number on both sides, so I know the answer is correct. That is the end of this mini lesson on solving two-step equations. Have a good day.